everyone, I'm Ari here at the New England District Championship event with Team 133 BERT. They have an excellent robot that excels at every aspect of the game. They have an under-the-bumper collector, an arm that pivots that can score in the amp and trap, and a phenomenal shooter. We're breaking down their robot here next on Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the Join button in any YouTube video to pledge your support.
The intake is used as an under the bumper because if we were to use it over the bumper, it would be destroyed in the fight for the middle notes in auto mode, and it also as an added benefit when we go to the source to pick up the notes, it doesn't take up a while to grab the note from waiting for the human player to push it out. Instead, as soon as they cross the midline, the note can be dropped and picked up immediately instead of having to wait a second. Plus, there's GoPro mounts to allow a GoPro to be there to record what's happening. It can't be on the scoring stage because it would be above the height limit.
Very interesting. So after you collect with your under the bumper intake, how does your handoff work? And what goes on with the arm system?
So the note will go from the intake up into the staging zone where it can sit through our polycord almost belts, and we can spin up our shooter wheels to send it into the shooter wheels or hold it for when the arm goes up to score an amp. The shooter will move up and down with a lead screw to get us an angle. We have a program that'll auto adjust once we hit a button on the controller to the right angle that we need to get it in the speaker.
So it's a fascinating subsystem. How did you come to the decision to use a lead screw for aiming your shooter?
Just seemed like a optimal decision, I guess.
Cool. And did you do a lot of different prototyping with how your handoff worked?
Yes. In the prototyping, we had a prototype originally with the wheels on the outside, well, left and right side, instead of on the top and bottom to shoot, and we found that it was just better for top and bottom because we can angle it a little bit.
Cool. So you have this subsystem and then it goes onto an elevator. Can you talk a little bit more about that?
So we originally experimented with a reverse virtual 4-bar, which would spin the staging zone all the way around for amp. But then that idea didn't end up working out, so we just went with a regular virtual 4-bar to keep the staging zone level so that it'll go up and be at the right position for amp.
Very interesting. So this is a very complicated robot with a lot of subsystems that have to work well together. How does your software work, and tell it what to do?
We're actually a bit funny with our code compared to other teams. We have everything in just like one file, or just about everything. A couple other things as well, but we're a bit different like that. So like the way our autos work, we've just got a bunch of stages set up in a switch case. So when making auto, like we'll watch our encoders and go through and figure out the encoder values that we need to be at for each stage. Like we're trying to drive out to say some spot far away, we'll reset encoders, turn to that angle, start driving that way. and then whatever our encoders are at there, we'll use with a PID controller to just go to that spot and tell the robot to drive to that spot. We're definitely a bit different with our auto. Like, I've talked to other teams about it, but I mean, it works. We've gotten a 6-piece off of it, so no path plan or anything like that, but just dead reckoning with encoders, preset values that we find experimentally. But it's all turned out pretty well in the end, so works for us.
Right. Well, that is certainly one way to do it, and 133, you are very successful with it. So speaking of seeing your robot in action, can we see some of the set points and various shooting positions that you have?
Yep. So I'm gonna show the arm. So we've got 4 different set points for the arm. First one, what we're at right now, is just all the way down, regular position when shooting and intaking. Our next set point is the amp set point, but we actually need a note in the robot to go to the amp, because we have sensors in there to make sure that the note's actually in there. It's more or less just as a protection from snapping the note, because when the arm goes up, it'll just hit on this bar over here, the note, and just slice it in half. We've done that in practice before. So our first main set point that we use is amp. It just goes up. We have Sear bore absolute encoder on our shaft over here to give us positions. That way we don't have to worry about resetting the arm in the same spot every single match. And then the next position is the max height, which is just that. This is what we start off with when doing trap. We'll just put the staging zone all the way up in the air, and then go through and stick our climber up as well. And then we can drive into the chain for trap and then climb all the way back up. We stick our climber all the way back down to the bumpers to get as much height as possible. And then once we're up there, we do our trap height, which is just moving the staging zone forward a little bit so that it's right up against the trap and we can just eject right into the trap.
That is very cool.
And after that, to finish off trap, we'll go back to max height and just go down a little bit on the climber. And that way we'll fall right back into just standing straight up.
So doing the trap is a bit finicky this season. Have you made any changes throughout the season to your robot that you want to share?
One of the most important things that we found right after we got the robot all together was that we needed this tongue in the front over here. We actually added it for the amp first, because first testing, it was too steep of an angle to go in regularly on the amp and too much friction. So we've got this flap over here. It's just a piece of polycarb, but we left the plastic cover on it that it comes with to reduce the friction a bit. And that's what we've been using to make sure that there's low enough friction to score an amp and trap all season.
Well, 133, this is an absolutely beautiful machine, and it has been wonderful seeing it on the field this season. So congratulations on an excellent season played, and it's been wonderful having you at New England District Championship.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.